Hello, this is section 6.1 normal distributions. So, normal distribution, if the random variable had a probability distribution whose graph is continuous, bell-shaped, and symmetric, it is called a normal distribution curve. So, mathematical equation for normal distribution, we are using these formulas where the E is almost approximates 2.718, pi is about the 3.14, and mu is the population mean, and sigma is the population standard deviation to compute this. Shapes of the normal distribution, so we already said that here, the normal distribution is going to be the continuous, bell shape, symmetric. So shapes of the normal distribution, shape of the and position of the normal distribution curves depends on two parameters, which is a mean and standard deviations. So same mean but different standard deviation, and then B, when a population mean are same, which is here, but the population standard deviation is different, then curve with a larger population standard deviation is more spread out than the smaller population standard deviation. So you can compare the two graphs of this and then this, okay? And then the different mean but the same standard deviation. So when the population standard deviations are the same but the mean are different, which is the curve has a same center, but at the center are the different point along with the x-axis. So they're talking about this. So they have a same standard deviation, but the mean is come out as a different place. All right, so let's go to the next page. So when you have a symmetric property of the theoretical normal distribution, a normal distribution is a curved bell shape, and mean and median mode locate the center of the distribution. And normal distribution curve has exactly one mode, normal distribution, which is highest place. And the normal distribution curve is continuous, having a no gap or holes for all values of independent variable. And then curve approaches but does not meet the x-axis, getting is increasingly close where while never touching the x-axis. The area, this is actually the total area under the distribution is always 1. And the area under the parts of the normal distribution that lies within one standard deviation means approximately, so one standard deviation of the mean proxy is 68%, and then two standard deviation of the mean is 95%, and then three standard deviation approximately 99.7%. It is known as a applicable. So area under the normal distribution, so I put down the curve for you. So about this is one standard deviation about here from here to here. So which is one standard deviation is this is, and then two standard deviations up to here actually, and then three standard deviation is up to here. So all the way here, and then this is actually that we call that as the outlier. All right, let's look at the next page. So normal and skewed distribution. So normal distribution is usually symmetric about the mean, and that is the data is even distributed about the mean. And the majority of the data value fall either to the left or right of the mean, the distribution is skewed, which is skewed is it's not symmetric. So which is going to be this case or this case. And then when the majority of the data is right of the mean, and then we call this is a negative skewed or left skewed. This is actually the place of the skewed. And the mean of the mean is less than the left of the median when the majority of the data is left of the mean, which is this case. So which is, this is a skewed place. So we call that as a positive skewed or right skewed. The mean is greater than to the right of the median. The tail of the curve indicates the direction of the skewness. Right is a positive, left is negative. So yeah, this is a normal distribution, and then this is skewed, and this is skewed case, and then this is left skewed, and this is the right skewed, and this is also the positive. The left skewed is sorry, but negative skewed, and this is right. The right skewed is positive skewed. Standard normal distribution. The standard normal distribution is the normal distribution with a mean of the 0. So we kind of converting it as instead of the mean, we put the 0. And then standard deviation is 1. So this is 1 standard deviation and 2 standard deviation and 3 standard deviation on both sides. So 1 standard deviation from the 0, 2 standard deviation from the 0, and then 3 standard deviation from the 0. So that one we call the standard normal distribution. Okay, and the formula, the standard normal distribution is y equal to this formulas. Okay, all right, let's look at the next page. All normally distributed variables can be transformed into the standard normal distributed variable by using the formula for the standard score. So the z, we call the z score, which is the value subtract the mean over standard deviation. So formula is this one, x minus mu over sigma. Standard score of or z-score. The standard score or z-score is number of the standard deviation that is a particular x value is from the mean. So we are using table E, give the area to 4 decimal places under the standard normal curve for the z values from negative 3.49 or 3.49. Technology can also be used to find the area under the standard normal distribution curve. So finding the area under the normal distribution curves. So step 1, we draw the normal distribution curve and shade the area under the consideration. Step 2, choose the appropriate type of problem. Either use a table E or use a technology to find the shady area. But I'm gonna use the table E, which is I'm gonna attaching the table into the module 6. So please take a look, and also I'm attaching the YouTube that shows how to find the probability, which is the area from the z-score. So number 1, find the area between the two given z value. So find the area under the standard normal distribution curve. So in here we have z equal to 0, which is 0 is right in the middle, and then z is a negative, so but very, very narrow. Okay, so about here, so negative 0.32. Okay, so we are looking for the area between the 0 and the negative 3.2. So find the area is probability, but the score that you're seeing from the table table E is always about, so whatever the area they're looking for, whatever number that is, okay, they always give you the area on the left. So in order to find the area in between, if you find the area, so which is a p is a z-score less than 0, and then subtract z is less than negative 0.32, and then you get the area of the between. So if you're looking at the z-score as a 0, which is a 0.00, it'll give you the 0.5. And then area, which is the probability is also the area too. Okay, so use a z-score, and then if you find the negative 0.32, and then it'll give us the 0.3745. And then it becomes 0.1255. So that's area between. Now I want to looking for the area to the right of the z equal to 1.23. So this is a 0 here in the middle, so about here, 1.23. Now this time you're looking for the area on the right. But the table E give you the area on the table on the left. So in order to find the other side, but area under the curve is always 1. So if you do it, this area, this is area for, I want to subtract 1 minus, and then if you find the area of this whole thing, which is the probability z-score less than 1.23, and then that will be give us the area of this one. So 1 minus, and then if you use a table E to find the probability of less than z is less than 1.23, give you the 0.8907, which is 0.1093. Okay. All right, let's look at the next page. Next page, now to the left of the z, so there's a 0 here, and then about this place a negative 1.03. So you're looking for the area about this curve. So you're looking for area, which is a p of z is less than negative 1.03. Use a z-score. It'll tell you 0.1515. Between the z equal to negative 2.15 and then z equal to 0.97. So your area is going to be the, so 0 here. So you got 1 is negative 2.15 and about 0.97. So you're looking for the area between this. So we already kind of did this. Okay, so all the area that you see from the table E is from the left side of the z. So if you use it as a p of z is less than 0.97, subtract p of z-score less than negative 2.15, which is use a z-score, you get the 0.8340 and subtract the 0.0158, and then you get 0.8182. Example 2. Find the probability for the regions between the two z-score this time. So find the probability using the standard normal distribution curve. So your probability is z is going to be the between the 0 and 0.92. So 0 here and then about here is a 0.92. So idea is the same, okay? So which means you can say the area, this is actually equal to, you can say P is Z is less than 0.92, subtract probability Z is less than 0, which give you the 0.8212 and minus 0.5000, and then you get the 0.3212. Probability z is less than 2.77, so this is the right middle is 0 and then about 2.77, and then you're looking for area less than the 2.77, which means if you look at the table E, it's going to be 0.9972. All right, let's look at the next page. Now you have z is greater than 1.12, which is a 0 here. So 1.12 is about here, which is you're looking for the area of this curve. So the number probability give you the from the table is the left side of the z. So in order to find this, you have to put 1 minus p of z is less than 1.12. And then it will be 1 minus 0.8682 becomes 0.1314. And also this is a 0 in the middle, and then about negative 1.20 here, about 1.56 here on the curve. And then we are looking for area of this one. So Same thing. So probability of z is less than 1.56. Subtract p of z is less than negative 1.20. And then it gives you the 0.9406 minus 0.1151 and then becomes 0.8255. Now, example 3, find the z values for the specific area in the tails. Find the z values, one positive, one negative, that are equidistant from the mean so that the area is a two-tail, totals of 5%, 2%, 1%. So, which means this is a normal distribution curve. So, two tails, which means your tail is at the on the right, on the left. So, 5%, if you divide by 2, it's going to be 2.5%, which is it's going to be 0.025, okay? So which means this is actually the area of the 0.025, and this is also 0.025, which is the same as added up as a 0.05. So what we do is we are looking for from the z, and then one number is going to be the area of the probably come out as 0.025. Okay, and then the number that you'll get as a z here, okay, is going to be the same number except the sign. So we are looking for that z score here. So z of negative 0.05. No, sorry. What am I talking about? It's going to be 0.025, and also this is actually, it's going to be 1 minus 0.025, which is 1 minus 0.025 is this is going to be 0.975. So which is we're looking for that score. So what we do is we're looking for this area as a z-score. So if you're looking for this area on the table, and then 0.05 is about negative 1.96. So answer is actually the 1.96. And also P of z greater than 1.96 is almost the 0.0252. Now we have a 2%. So 2% is less area than the 5%, of course. So 2% is about here. So which is this much is 0.01, and this much is another 0.01 on two tails. So what we do is z is a p of, what am I doing? So p of z is, so one number, it's going to be about 0.01. So we're looking for z sub, alpha is area 0.01, or z sub, and 1 minus 0.01, which is z sub 0.99, right? So if you're looking at this is the area. These are the area. And then what z-score close to that, which is this is going to be the negative 2.33. So this is equal to negative 2.33. And this one is same as a z-score of what? Is greater than 0.01, right? Which means 0.99, so it's going to be 2.33. So always a symmetric. And then also now 1%, which is, oh my goodness, very small, right? So 1% is same as 0.01, and then divide by 2, we got 0.005, right? So this is a 0.005, another area here 0.005, right? So same thing. So we're looking for z sub 0.005, z sub 1 minus 0.005, which is 1 minus 0.005 is 0.995 as a z-score. So the probability of the z-score less than what is going to be 0.005. So this is the area. So when you're looking for that, and this number says negative 2.58. And also on the other side is going to be P of Z is greater than one number is going to be 0.005. And then also another number is, which is going to be the 0.995. Oh, no, I'm sorry. What am I saying? It's going to be the positive of 2.58. Okay, so almost the 3 dot. Okay, so I think that's all for the normal distribution. All right, thank you for listening.